Greetings of the day. In the last session, we discussed about helium neon laser, its construction part and working and its application. In today's session, we are going to discuss another laser, that is ruby laser, its construction and working, and some applications of laser. So in this session, we are going to cover this topic. If you see ruby laser is a solid state laser. The ruby laser is a solid state laser. And see, this is the first laser device which was designed after the theoretical applications, theoretical explanation of production of laser. And this ruby laser is a laser which produces pulsed output. Pulsed laser as output. So the output of this laser is not continuous. It produces pulsed laser as output here. Now if we see the construction part of this laser, the laser contains the ruby rod. This is a ruby rod. This ruby rod is a combination of two compounds. One is aluminum oxide. So the aluminum oxide is doped with the chromium oxide. So when the aluminum oxide is doped with the chromium oxide, now see, the aluminum concentration is 99.95%, whereas the chromium oxide combination is 0.05%. So when the aluminum oxide is doped with the chromium oxide, so the positions of aluminums are occupied chromium ions, and these chromium ions are responsible for the production of laser, and therefore these chromium ions are called these chromium ions occupy the position of aluminum ions, and these chromium ions are responsible for laser, and therefore they are called as active centers. The chromium ions are responsible for the production of laser because the chromium ions contain metastable states. And from these chromium ions, laser will be produced, and therefore the chromium ions are called active centers. And this aluminum oxide Al2O3 is called active medium because this medium helps the chromium ions for the production of laser. Therefore, this aluminum oxide is called active medium. Now, if you see this ruby rod, it seems to be like a pink color. And this ruby rod, the end surfaces of this ruby rod are polished or grounded and polished with silver. So one end is this end is highly polished with silver, and therefore it acts as fully reflecting mirror surface or 100% reflecting surface. The other end is partially coated with silver, and this will act as partially reflecting surface or partially reflecting end. So in the solid state laser, what we do is, we don't take the external mirrors to form optical resonator. The end surfaces of the active medium are grounded and polished with silver such that one surface will act as 100% reflecting mirror and other surface act as partially reflecting mirror. So therefore the end surfaces of the ruby rod act as optical resonator. The end surfaces of this rupee rod act as optical resonator or optical cavity. And this rupee rod is enclosed in a glass tube which contains the inlet and outlet for the flow of coolants. And this is surrounded with a flash lamp in helical shape. Now see, this is a xenon flash lamp. This is xenon flash lamp, which is in the shape of helical shape, and it surrounds the ruby rod. And these xenon flash lamp will produce high energy light flashes, and these flashes will incident on the ruby rod. And see, the inner surface of this glass tube are coated in such a that the light incident on the walls also reflects from these walls and incident on the ruby rod. That means whatever the energy which is emitted by the flash lamp is made absorbed by the ruby rod to attain population inversion. Now see, these xenon flash lamp act as pump source. So in this case we are using xenon flash lamp as a pump. So therefore this optical method is called as optical pumping. This pumping method is called as optical pumping. So already we discussed that laser contains three major components. One is active medium, one is pump source, and next one is optical resonator. Now see here, the ruby rod is a combination of aluminum oxide and chromium ions. The chromium ions produce laser, therefore they are called as active centers, and aluminum oxide is called as active medium. The end surface of the ruby rod are made to act as mirrors or reflecting surfaces. Therefore, the end surface acts as optical resonator. And the xenon flash lamp is surrounded with ruby rod is surrounded with xenon flash lamp, which is in the helical shape. And these act as pump source, and the pumping method is optical pumping. Okay. Now, if you see working, now see here in this arrangement, when the power source is switched on, that means when it is activated, when the power source is activated, the xenon flash lamp will produce light flashes of high energy. And this the inner surface of the glass tube is coated in such a way that the light reflected from the glass tube will incident on the ruby rod, and the light is absorbed. When the light is absorbed by the chromium ions here, so initially the chromium ions are at ground state. So this is the energy level diagram of chromium ions. This is the energy level diagram of chromium ions. So when the light is absorbed by the chromium ions, this incident photon is absorbed by the chromium ions, and the chromium ions goes to excited state, E3. Now E3 is a higher energy state. E3 is a higher energy state. And here, these chromium ions stay for a time of 10 to the power of minus 8 seconds. 10 to the power of minus 8 seconds. Once the time of 10 to the minus 8 seconds completed, it is not a metastable state. E3 is not a metastable state. That's why lifetime in E3 is 10 to the minus 8 seconds. And these chromium ions make spontaneous emission and come back to E2, and E2 is a metastable state here. And these metastable states have a time of 10 to the power of minus 3 to 10 to the power of minus 6 seconds. Therefore, it is the last time. Therefore, as the xenon flash lamp is continuously emitting light pulses, and these light pulses are absorbed by the chromium ions, and they go to E3 and they go to E1. As after a certain time, the chromium ions accumulate at E2. The chromium ions accumulate at E2. As the chromium ions are accumulated at E2, we get a condition that the population inversion between E2 and E1. That means there are more number of chromium ions are there in E2 and less number of chromium ions there in E1. Therefore, the population inversion is achieved between E2 and E1. Once the population inversion is achieved between E2 and E1, at any moment of time, a spontaneous emission will take place between E2 and E1. This spontaneous emission will produce a photon of energy E2 minus E1. And this photon, if this photon is parallel to the axis of the optical resonator, this photon is reflected back. After reflecting, it acts as incident photon. As already the population inversion condition is achieved, this photon acts as incident photon and triggers one chromium ion to E1. And we get two photons. And the incident on 100% reflecting mirror or fully reflecting surface. They reflect back. And the 2 becomes 4 and 4 becomes 8. Like this, the stimulated emission starts. So it leads to emission of stimulated emission. So stimulated emission takes place here and laser output will be, we get laser as output. So as this stimulated emission goes on, once the certain intensity of light is achieved, so laser will be emitted out with a wavelength of 6943 angstroms from the partially reflecting mirror. Now see here. So we get a laser of wavelength 6943 angstroms. Now see, after a certain time the stimulated emission takes place. Stimulated emission continually increases and photon density increases. As photon density increases, the intensity of light also increases. Once the required intensity of light is achieved, the laser will be made to pass through partial reflecting mirror. Some part of the laser is allowed to pass through partial reflecting mirror, and therefore we get laser as output. In this ruby laser, the output wavelength of the laser is 6943 angstrom, and this falls in the region of red color or visible spectrum of red color. So here also the ruby laser also produces red color laser as output. And now see, in this ruby laser, we are making the chromium ions to go to E3 and E2. As time goes on, chromium ions accumulate at E. After a certain time, even though the xenon flash lamp produces light flashes, there will be no chromium ions in E1 to absorb the light energy, and they go to E3 because most of the chromium ions are accumulated in E2 and few are in E3, and there will be no chromium ions in E1. That means for a certain time it stops to produce laser. So it produces laser for a certain period of time, and it stops for a certain period of time, and again it produces laser. Therefore, the output of this ruby laser is pulsar laser. Pulsar laser. Also, we have discussed in last session that while discussing pumping schemes, when a laser is produced by 3-level pumping scheme, here it is 3-level pumping scheme. The output of laser from the 3-level pumping scheme will be pulsar. So, from the ruby laser we can get an idea that when we use a 3-level pumping scheme for the production of laser, the laser will be pulsar laser as output. So these are only drawbacks in pulsar laser, from ruby laser. As well as most solid state lasers will produce pulsar laser as output. And some other solid state lasers also are there which produce continuous laser as output. So these are about ruby laser. If we see some of the applications where these pulsar lasers or the solid state lasers are used in industry, you see some videos here. You can see this video here, where you can see here pulsar laser. You can see the laser is drilling the metal here. You can see clearly the sparks of laser. Here you can see it is a pulsar laser output there. So here this is one of the solid state laser which will produce a pulsar laser output, and this pulsar laser is used for drilling. So we cannot declare that the pulsar laser cannot use anywhere. But in most of the applications, the pulsar laser also used. So depending upon the type of the application where you are using laser, we want to choose either the pulsar laser or continuous laser. So in the case of drilling purpose, it is suggested to use only pulsar laser. Why? Because for drilling holes we need some gap there. So metal should not be drilled continuously. Metal should drill at some point and should not drill at some further point. So here in this case we use a pulsar laser here. And you can see here, this is one of the applications of laser where you use the laser is using for cutting. And see, you can see here what type of laser it is here. So it is also a red color visible laser. So you can see the glass is going to be cut in a definite shape by using a laser. Now you can observe here the laser uses continuous laser because the glass surface has to be cut continuously. So therefore here we are using a continuous laser. So these are the industrial applications where the metals or glasses or fibers are cutted in a design shape and design structure. You can see here. So these are cutted material. Okay, you can see one more. Now you can see these are application of welding. Now see here a sharp metal is going to weld on the surface of a box here. You can see here. Now see this is the metal which is going to be welded here. Now see what type of laser. If you observe very clearly, here the type of the laser used is welding. You can see this is the surface welding here. This is the laser, and this material is going to be welded on the top of the surface. You can see sparks of laser there here. So around the edges of this box, it is going to be welded on the surface there. So this is called plate welding there.
We have completed Ruby laser. If you see the applications of laser, the lasers are used in different fields. The lasers are used in industries. For medical applications, lasers are used. So lasers are used in commercial applications, science and technology, and defense applications. If we see the industrial applications, lasers are used for cutting the metals. So to cut the metals in different shapes, lasers are used. Similarly, the lasers are also used for welding of different metals. Okay, different metals can be welded to form a single component. So there lasers are used here. And lasers are also used for drilling the holes in the metals of desired size and shape. And these lasers are also used for surface hardening. So in some metals, hardening of the surface plays an important role. So the lasers are used for surface hardening in industries. And if you see the medical applications, lasers are used for eye surgeries. That means to solve the problems of eyesight by retina reattachment. And lasers are used for removing of tattoos. And for dental surgeries as well as bloodless surgeries, lasers are used in medical applications. And lasers are also used in cancer treatments. For treatment of tumors in the body, lasers are used. So these are the some of the applications also there. So there are so many medical applications where lasers are used for treatment purpose. If you see the commercial applications, lasers are used as laser printers. Today we have laser printers, and the lasers are also used as laser pointers, and lasers are also used for reading of barcode readings in shopping malls or in supermarkets. So lasers are used for reading of barcodes, and lasers are also used for laser shows. So today one of the commercial application is laser shows. Okay, and if you see science and technology applications, lasers are used for laser cooling. So we know that laser having a produce a large amount of heat energy. So therefore lasers are used for heating purpose. On the other side, the lasers are also used for cooling purpose, where the trapping of atom takes place to study the properties of the materials. And the lasers are also used for nuclear reactions. So in order to initiate nuclear fission and nuclear fusion reactions, so lasers are used in nuclear reactions. And if you see defense applications, lasers are used as death ray devices, where laser is exposed to the other enemies, which results in the death of the enemies. So laser death rays. And lasers are also used as range finders to find the distance of the target. So these are the applications of laser. As well as the lasers are also used in used for LIDAR application. That means light detection and ranging. So same application of sonar. So in the sonar, in the radar they use radio waves, and in sonar they use sound waves, and in LIDAR they use a laser beam to study range of the target and detects the target there. So these are the applications. So with this we complete laser. Thank you.